Hi all, today we will discuss about a special topic called direct memory access. So it is one of the direct memory access technique is one type of IO data transfer technique. So the DMA stands for direct memory access, and it is one of the IO data transfer technique. Let us see the importance of direct memory access. See, whenever we discuss about IO data transfer techniques, the first one was programmed IO, and second one was interrupt initiated IO data transfer technique. We already discussed in the previous lecture that the advantage of interrupt initiated IO is that CPU need not to be in the loop status or continuously waiting status to check the device status. So the interrupt, for that reason we uh, discussed a new technique called interrupt initiated IO. And where in the problem with the interrupt initiated IO is that the problem with interrupt initiated IO is that this interrupt initiated IO is suitable when you have only small amount of data to be transferred, because if there is a large amount of data to be transferred, then interrupt initiated IO will not work, because uh, when you have a large amount of data, let's say I have some 40 KB amount of data to be transferred, then for each KB, if you generate interrupt, then what happens, the processor is, so 40, the processor has to serve 40 interrupt requests, 40 INT or 40 interrupt requests. And the problem with this is that processor will have to process these 40 interrupts request signals, and processing of an interrupt request signal uh, takes considerable amount of time, because all of you know that it has to complete the current instruction execution, and it has to uh, load the content of the PC, that is the address of the next instruction, into some temporary buffer, and it has to save the status of the registers, and then execute an interrupt service routine. So all this takes considerable amount of time. So if the processor gets more interrupts to transfer large amount of data, processor is busy in servicing interrupt itself. Processor will become busy in servicing the interrupt, in processing the interrupts rather than executing the instructions. So it again delays the execution time of the processor, execution time of a program, and also processor time is getting wasted. So the interrupt initiated IO is best suitable if you have small amount of data to be transferred. But for the case of large amount of data, this this interrupt initiated IO will not work. So it's required to discuss or have its another important technique, that is DMA, direct memory access. So the goal of the direct memory access is that it has to transfer large amount of data. It has to transfer large amount of data. This should be the goal of the direct memory access. So our goal is to transfer the huge amount of data or large amount of data. So direct memory access or DMA means the CPU grants IO module authority to read from or write to memory without involvement. So what happens here? DMA means this processor will not transfer the large amount of data. It handovers the job to dedicated IO module or IO module authority. IO module authority means there will be a dedicated processor. IO, you can call it as DMA processor. So it is a dedicated processor and its job is to transfer the huge amount of data. DMA module itself controls uh, exchange of data between the main memory and the IO device. So the earlier what was happening, if this is my processor and this is an IO interface, and if this is my IO device, so the processor will not involve in processing the in involving if I have large amount of data to be transferred. Ultimately processor will send it to some main memory. Remember, now this data has to be transferred to main memory. Without involvement of the processor, there is another component comes into the picture which is called DMA. So the DMA module itself controls exchange of data between main memory and IO device. CPU is only involved at the beginning and the end of the transfer and interrupted only after entire block has been transferred. So entire block. So entire block means when you have large amount of data. When you have huge amount of data to be transferred, when you have large amount of data to be transferred, then we use DMA. That is nothing but direct memory access without involvement of the CPU. So here DMA, what happens? Without involvement of the processor, the large amount of data can be transferred to and from main memory to IO devices. It is called DMA. So let's look at some picture how DMA controller works. So here I have this is my main memory, and see, this is an input device, that is USB drive. Hard disk is another IO device, and next printer is an output device. So for each device you can see a device controller over here. So this is nothing but IO interface. So these device controllers interacting with DMA, which transfers the data to and from main memory using data bus without involvement of the processor. So let me repeat this once again, try to understand. The DMA controller manages the data transfer, arbitrates access to the and arbitrates access to the system bus. So the goal is, now the data is here. So this data has to be transferred via DMA to main memory. This data has to be transferred. How? And from main memory, via DMA, data has to go to printer. So here everything revolves around DMA. How DMA manages the data transfer means by using data bus. So remember, for each device we have a device controller. These device interact with the device controller. Device interacts with DMA. DMA sends the data to main memory. So here three types of communication here. One is input and output devices to device controller to DMA, DMA to main memory. So now the goal is, the problem is, when DMA is transferring the data by taking hand controller to the data bus, what processor is doing? It is one of the biggest question. Whether we have to keep the processor busy for that period, or whether this processor, and now the DMA and processor both are competing for the data bus. Remember, the processor and DMA both are competing for data bus. Both are competing for the data bus. When one DMA, one entity is handed over or taking the control of data bus, what processor is doing, should do? It's the biggest question. So we'll discuss all these things. So now you should get an idea that the DMA now is a uh, is like much like a processor which dedicatedly used. This DMA is dedicated for performing IO operation, that too transferring large amount of data. Next, we see the data transfer modes in DMA. We have various data transfer modes in DMA, such as DMA can be transferred in several different ways under DMA controller. So the DMA can be transferred in several different ways under the DMA control. First one is DMA block transfer. The first technique is DMA block transfer. So in DMA block transfer, in this mode, the block of data of arbitrary length can be transferred in a single burst. Next one is, so DMA block transfer, what it says, transfer the entire block. If this is my data to be transferred, and this you are calling as one block. So the DMA has to transfer entire block. So here I have one block 1, block 2, block 3. So the entire block has to be transferred to main memory. It is one type of data transfer mode. Second one is cycle stealing mode. Cycle stealing mode means here the DMA controller is allowed to use the system bus to transfer one word at a time. So one word at a time. After which it must return control of the bus to CPU. That means, so here what happens, so if I have some block amount of data, if this block contains 4 memory words, then one word is transferred, one word is transferred to main memory by taking the control of data bus. Then it must return the data bus to processor. Next, after next cycle, second word has to be transferred to DMA, DMA to main memory. So here entire block is not transferred in one shot. For each cycle, one word is transferred, or at alternate cycles. So the processor and DMA both are sharing the system bus. This is called cycle stealing mode. And the third approach is DMA, transparent DMA. So in transparent DMA, what's happening in this mode, the DMA is allowed to steal only those cycles when CPU is not using system bus. So as I said earlier, here processor and DMA both are competing for system bus. So when both are competing for the system bus, they can be transferred to the transparent DMA. What is it in this mode? The processor and DMA. When processor is not using system bus, when it is not using system bus, then this DMA can use the system bus only when processor is not using that system bus. This is called transparent DMA. So we'll discuss in detail what are those techniques. See here, the direct memory access. The direct memory access IO technique provides direct access to the memory while the processor is temporarily disabled. So why it is named as direct memory means it can directly, this DMA can directly access main memory without involvement of the processor. So the IO devices are connected to the system bus via a special interference circuit known as DMA controller. In DMA, both CPU and DMA controller have access to the main memory via shared system bus, having the data, address, and control line. So remember, you have to understand that whenever I refer as a system bus means it contains three components: address bus, data bus, and control bus. So these three together we call as a system bus. Address bus, the data bus, and system and control bus. These three together we call as a system bus. And now the both processor and DMA are competing for the system bus. How to manage the system bus is the main thing in DMA. Both CPU and DMA controller have access to the main memory via a shared system bus having data, address, and control lines. It is sometimes referred to as a channel. In an alternate configuration, the DMA controller may be incorporated directly into the IO devices. Of course, in some devices, the DMA controller can be placed in the IO device itself. So a DMA controller, what it does, it temporarily borrows the address bus, data bus, and control bus from the microprocessor and transfers the data bytes directly between the IO port and a series of memory locations. The DMA transfer is also used to do high-speed memory to memory transfer. So the DMA transfer is also used for high-speed memory to memory transfers. So DMA transfer can be done in two ways. One is DMA transfer blocks, another is cycle stealing, and also transparent DMA. But the much more popular one are the two techniques, that is DMA transfer blocks and cycle stealing. Remember the important techniques in uh, DMA transfer is, first one is DMA transfer blocks and second one is cycle stealing. So this is cycle stealing and DMA transfer blocks. So these are the two important techniques. Now let's look at the diagram. That is, here we have a disk and we have a disk controller or DMA controller. It is a network interface which is also connected to DMA controller, and these are the printer and keyboard which have a dedicated device controllers. So these are sharing system bus. This is my processor and this is the main memory, and here the goal is to transfer data via the system bus to main memory or main memory to device controllers. Similar network interface to main memory or main memory to printer, keyboard to main memory. But here the block of data has to be transferred. Block of data or large data has to be transferred. So why DMA means an important aspect of governing the computer system performance is the transfer of data between memory and IO devices. It's an important aspect of governing the computer system. The operation involves one of the important aspect of the computer system performance is that how quickly the data can be transferred from between memory and IO devices. The operations involves loading the programs or data files from disk into memory, saving files onto the disk, or accessing virtual memory pages on a secondary storage medium. So these are all called. So the programs can be loaded, data can be loaded from hard disk into the main memory, which also involves the DMA, because you need to transfer huge amount of large size program or huge amount of data from hard disk to main memory. And also you want to save some larger uh, log file of a server log file into the hard disk, or during the virtual memory pages, the pages has to be transferred from secondary storage hard disk to main memory. So the process would be much quicker if you could bypass the CPU and transfer data directly from IO devices to memory. Direct memory access does exactly that. So during DMA transfer, the CPU is idle and no control of the memory buses. So we'll see the types of data transfer. One is DMA transfer block, and so in this DMA data transfer block, in this DMA mode, the DMA controller is a master of the memory bus. This mode is needed. This mode is needed by secondary memory like disk drives that have data transmission and are not to be stopped or slowed without any loss of data transfer nodes. So this DMA transfer block is technique is used when you want to transfer the data from hard disk to DMA controller via DMA controller to main memory. So the block DMA transfer supports faster IO data transfer rates, but CPU remains inactive for a relatively longer period by tying up system bus. So the disadvantage is that the processor has to be in idle state. The processor has to be in ideal state for longer period. This is the disadvantage of DMA transfer block technique. Next, we have seen the cycle stealing technique. So in cycle stealing technique, what's happening in this method, uh, system allows the DMA controller to use system bus to transfer one word. So it just to transfer one word, after which it should return back the control of the system bus to CPU. So this method reduces maximum IO transfer rates. It also reduces interference of DMA control and in CPU memory access. So in this case, CPU cannot be sit idle for longer period. It is completely eliminated by designing DMA interface so that system bus cycles are stolen only when CPU is not actually using the system bus. This is called transparent DMA. So the advantage of the cycle stealing method is that the processor, what is cycle stealing? In cycle stealing, what's happening? Let's assume this is one cycle, this is another cycle, this again another cycle, this is again another cycle. So total we have one cycle 1, cycle 2, cycle 3 and cycle 4. So these are called cycles. So in this cycle, now the goal is who has to share system bus. First, processor, during cycle 1 processor gets the control of the system bus, and in the next cycle DMA gets processor DMA, and third cycle again processor, fourth cycle again DMA. So in cycle 1 processor, cycle 2 DMA, cycle 3 again processor, cycle 4 again DMA. So on an alternate cycle 1 and cycle 3, CPU is getting, cycle 2 and cycle 4, the DMA is getting the control of the system bus. So this is about cycle stealing method. You can see that both processor and it looks like both processor and DMA both are busy. They are not both are not sitting idle for longer period of time. So this is the advantage of the uh, cycle stealing method. But the disadvantage is that it takes longer time for DM in this technique, cycle stealing technique, to transfer the large amount of data. If I have some megabytes or gigabytes of data to be transferred, and if only one word is data, see, and also one more thing, and this DMA transfers one word. This DMA transfers one word. This DMA transfers one word, not a complete memory block. If the block contains some 1,000 memory words, then it takes 1,000. It requires 1,000 cycles of system bus. So it may take longer time. And the third, there is also a third approach which we call transparent DMA. In that technique, what happens? The processor, when processor is not using system bus, so can you guess when the processor will not use system bus? Means, for example, during, let's take instruction execution. Instruction execution, what happens? This is used only during fetch. During fetch it requires system bus. Your decode doesn't require any system bus, and also execute may not require. So during these phases it can use uh, it can use so during this decode stage or execute stage, the system bus is idle. The system bus is idle. System bus is idle. Then DMA uses those system bus. It is called transparent DMA. So this technique is called transparent DMA. So the transparent DMA technique works like so. This is about DMA. So we will see before going to priority of interrupts. The next topic is priority of interrupts. So before going to discussing about priority of interrupts, let us discuss the brief introduction about a brief recap of interrupts. So the type of interrupts. Generally, the interrupts are of two types. One is hardware interrupts and other is software interrupts. Next, so interrupts are of two types. One is hardware interrupt and the other is software interrupt. And in hardware interrupt we have maskable interrupt and non-maskable interrupt. So a hardware interrupt can be masked. So how you can mask an hardware interrupt? First, what is an interrupt? Interrupt is some kind of disturbance to the processor. What is this disturbance means? So remember in the last lecture we discussed if this is my IO device and this is IO interface and if this is my processor, the IO interface sends INT or interrupt request to the processor when the IO device is ready. Ready for what? Ready for sending the information or receiving the information. So when IO device is ready, it informs, it updates the status register, it sends some signal and the IO to the status register. It maintains the status register of each input device. So it updates the status register that I am ready. So with this IO interface understand this, yes, I need to generate a interrupt to the processor. So this is called hardware interrupt. There is also software interrupts. We'll discuss about that. So the hardware interrupts are of two types. One is maskable and the other one is non-maskable. See, it is in the hands of the programmer. The programmer can mask an interrupt, can unmask an interrupt. That is hardware interrupt. He cannot mask or unmask a software interrupt. He can mask and unmask only hardware interrupt. So how you can do that means by using a special bit called interrupt enabled bit. There is an interrupt or processor status register, short form. There is a special register in the processor which is called processor status register, which contains a bit IE. IE stands for interrupt enable. So you can set this interrupt enable to 0 or 1. 0 means it is a mask and hardware interrupt. So if it is 1 means unmask hardware interrupt. So 0 if the programmer sets IE to IE value to 0, then hardware interrupt cannot be generated. Similarly, if the programmer sets IE bit to 1, yes, hardware interrupt can be generated. Masking means processor can't accept any hardware interrupt. Unmask means yes, the processor can accept interrupts. So the interrupts is of two types. One is hardware interrupt and software interrupts. And in hardware interrupt, again two types: maskable interrupt and non-maskable interrupt. So let us see some examples of hardware interrupts. If the signal for the processor is from external device or hardware, it is called hardware interrupts. As simple as that. If the signal means interrupt request signal. If the interrupt request signal for the processor is from external device or from the hardware, if it is from IO interface, if IO interface is sending an interrupt request, so the hardware interrupt is like if the processor receives a signal from, if this is my IO device, this is my IO interface, and this is my processor. So when IO device sends ready signal to IO interface generates a interrupt signal, that is called INTR. This is called hardware interrupt. Why? Because here hardware is generating an interrupt. Hardware is generating an interrupt. So this is called hardware interrupt. This is the best example. Keystroke. The examples of the hardware interrupts are keystrokes, pressing of key on the keyboard, and mouse movements. These are the examples of hardware interrupts. The keystroke or mouse movement or the hardware interrupts. It doesn't mean that every keystroke generates an interrupt. See, when you type a word, when you type a data, it has to be a complete memory word. Then the IO interface generates an interrupt. So if you look at hardware interrupts, as I said, hardware interrupts are let me draw the picture. This is my IO device which sends IO interface. See, IO interface contains some logic, some status registers, and some data registers or buffers, and they send to some processor. So they contain some buffer, status register, and it contains one logic. When it receives ready, that means keyboard enters the data, keeps on enters the data, and the data goes to data register. When it becomes one memory word, then IO interface generates an interrupt, INTR. And this interrupt is of uh, two types: hardware interrupt. One is maskable interrupt and another is non-maskable interrupt. So the maskable interrupt means the hardware interrupts which can be delayed when a much higher priority interrupt has occurred to the processor. So maskable interrupt means, let's assume I have two interrupts from two different devices. So let's assume I have interrupt request 1, interrupt request 2. This has got P1 priority, highest priority, and this has got lowest priority. And let's assume another interrupt request 3. This has got P3 priority. P1 priority is greater than P2 priority greater than P3 priority. If this is the case, then accept this interrupt request 1, that is priority 1. These interrupt request 2, interrupt request 3, these are called maskable interrupts. Why? When interrupt request 1 is being processed, interrupt request 2 cannot be generated. By that way, it is called masked. Similarly, when interrupt 2 or interrupt 1 is getting processed, interrupt 3 cannot be accepted, generated. So this is called maskable interrupt. So if I have 10 interrupts, except the first one, the 9 can be categorized as a maskable interrupt. And non-maskable interrupt means the hardware which cannot be delayed and should process by the processor immediately are called non-maskable interrupts. So non-maskable interrupts means they should not be delayed. They should be processed by processor immediately. Such interrupts are called non-maskable interrupts. And we have another type, that is software interrupt. A software interrupt is a type of interrupt that is caused either by a special instruction in the instruction set or by an exceptional condition in the processor itself. The best thing is divide by 0. It is an exception. The processor generates it. It's a software interrupt. Or your instruction set, your program can also itself support to generate an example. So it has given, right? So it is generated when divide number by 0 or accessing unavailable memory. In both cases, memory out of exception or divide by 0 exception, these are called interrupts, software interrupts. Now, if you look at the priority, first priority is given to hardware interrupt, second priority is given to programmer software, third priority given to timer, fourth priority is given to input and output devices. So the hardware priority has got highest priority. Then if your program generates any exceptions like divide by 0 or memory out of bound exception, they are given second priority. The timer is given third priority. We'll discuss what is that. Fourth priority is input and output devices. This is the introduction about priorities.